Welcome to my presentation. My name is Meike BRANDES. I'm working at the Julius Kühn Institute, the Federal Research Center for Cultivated Plants in Germany. And in the next few minutes, I would like to give you an overview of major insect pests in Europe and IPM options. I started a little questionnaire and asked several colleagues in Europe to name the main insect pests in their country, to list the insecticide control options that are available in their country. I asked them if there are resistant pests, and I asked them to list non-synthetic chemical alternatives commercially available or management options used by farmers, and I asked them if they see future options on the horizon or in the research pipeline in their countries. And I get answers back from 12 European countries. And here are the results. Here you can see a map of Europe with the different countries. I included numbers in the different countries. And the number 1 means that the colleague said Pseudodes chrysocephala, the cabbage stem flea beetle, is a main insect pest in our country. Number 2 means Brassicogetes aeneus, the pollen beetle, is very important in our country. 3 means Zeuteruntius napi, the rape stem weevil, is an important pest in this region. 4 means Zeuteruntius pallidactylus, the cabbage stem weevil, is important. 5 means that Zeuteruntius acidimilis, the cabbage seed weevil, is an important pest in this country, alone or in combination with the Brassica podmidge, Dasyneura brassicae. One colleague said in Serbia, Philotreta subspecies are very important, as well as Atalia rosae. And 8 means that Zeuteruntius pizzicatus, the rape winter stem weevil, is an important pest in France or as well as in southwest Germany. Most of the colleagues said that Pseudodes chrysocephala is a main insect pest in their countries, as well as Brassicogetes aeneus. And half of the colleagues said that Zeuteruntius napi is very important in their region. The other pests listed below are more or less important depending on the situation in the countries. The next slide shows the insecticide control options available in the countries. In all the European countries, pyrethroids are available to control insect pests and oilseed rape. I didn't list all the active ingredients of the pyrethroids here because it's quite a lot. There are several type 2 pyrethroids available, as well as a few type 1 pyrethroids, as for example taufluvalinate. This insecticide class is in many cases the only control options for insect pests. In some countries, the active ingredient acetamiprid, a neonicotinoid, can be used to control pollen beetles as well as indoxacarp. In Switzerland, spinosad can be used to control pollen beetles. In UK, pymetrozine is available for controlling pollen beetles. And in France, organophosphates can still be used for controlling pests and oilseed rape. And there are several countries where insecticide as a seed coating can be used with the active ingredient cyantraliliprol or fluororadiofuron, but there's only a little effect or no effect on the cabbage stem flea beetle. Cyantraliliprol has an effect on the cabbage root fly, Delia radicum, but as I said, less effects can be seen on the cabbage stem flea beetle. Some insect pests and oilseed rape are resistant, especially to pyrethroids. Brassicogetes aeneus, the pollen beetle, is resistant to pollen beetles in nearly all over Europe. Some countries said that they've seen resistance to pyrethroids also in Pseudoiotis chrysopcephala, the cabbage stem flea beetle. In most cases, it's knockdown resistance that is known as this species. It's a Tageszeit resistance. But in most of the countries, field control with pyrethroids is still working. There is another situation in UK. They have an additional resistance mechanism. In addition to the knockdown resistance, they have also metabolic resistance, and field control is very difficult. There are also knockdown resistances known for several Zeuterinthius species, as Zeuterinthius assimilis, Zeuterinthius palidactylus, and Pizzitasis. And one colleague in Czechia said that in Zeuterinthius napi also pyrethroid resistance is known. Here are the results for the non-synthetic chemical alternatives commercially available or management strategies which are used by farmers. Some colleagues said that trap cropping is used as a non-chemical alternative, as well as undersowing or undercropping, but this is scientifically unproven. The colleague of Luxembourg said that they use a mixture of an early flowering oilseed cultivar to a late flowering cultivar, and this is very effective to control the pollen beetle. In Sweden, Requiem prime can be used. It's a blend of terpenes, botanical insecticides. In Switzerland, kaolin can be used to control pollen beetles. It's a mineral used as a spray. In Estonia, Nemetzahl is available for controlling insect pests. And also in Estonia, they try to enhance the naturally occurring predatory arthropods, including parasitoids, by heterogenic landscapes, semi-natural habitats, or field hedges. Future options on the horizon or in the research pipeline. That's what came back from most of the colleagues. Big question marks. But some colleagues had ideas. They said that they see future options in the usage of essential oils or botanical insecticides as azadirachtin. Some colleagues said push-pull strategies might be a future option, as well as entomopathogenic fungi, nematodes or bacteria. There's a lot of work at the moment to breed resistance cultivars, and some companies also work on the RNAi technique to control insect pests. So a little summary at the end. The main insect pests that were most frequently listed by the colleagues were Pseudoiotis chrysopcephala, Brassicogetes aeneus, and Zeuterinthius napi. The other insect pests are more or less important in the country. Insecticide control options that were listed: pyrethroids, the most important insecticide class for controlling insect pests and oilseed rape. And in some countries there are alternative active ingredients available as indoxacarb or acetamiprid to control the pollen beetle. But for many insect pests, only pyrethroids are available. So there are some resistant pests available in Europe. The pollen beetle show resistance all over Europe. In some countries, Pseudoiotis chrysopcephala developed resistance to pyrethroids. Here, knockdown resistance is known, as well as in some Zeuterinthius species, as Zeuterinthius assimilis, palidactylus, and Pizzitasis. the most frequently listed non-synthetic chemical alternatives or management options that are used by farmers were trap cropping and undersowing or intercropping. And future options on the horizon or in the research pipeline were resistant cultivars, entomopathogens, RNAE technique, or botanical insecticides. Last but not least, I would thank you for your attention, and thanks a lot to the colleagues in Europe.